We expect the digital world to wait on us. You tap a button to order food or swipe a screen to send a message, and you anticipate an immediate, frictionless response. But reality is much more violent. In the exact moment your thumb presses the glass, the phone is entirely dark to what you want. This physical tap triggers what engineers call a cold start, a tiny hidden window of time where a dormant application has to wake up and completely assemble itself from scratch. Because human patience is so incredibly short, our absolute intolerance for waiting has forced software engineers into a high-stakes, invisible war fought over fractions of a second. Before that tap, your phone's memory is perfectly still. The applications are not running quietly in the background waiting for their cue. From a hardware perspective, an unopened application is a compressed, inert brick of files in storage. The second you ask an app to open, a countdown begins. The system has a strict limit of 400 milliseconds to unpack gigabytes of data, configure internal settings, and physically draw a visual interface. If the hardware breaches that 400 millisecond threshold, your brain registers a microscopic delay. You subconsciously feel the application is broken, and you close it. Opening an application requires the total resurrection of a dead system, all executed against an impossible ticking clock. If we advance the timeline into the 100 to 250 millisecond window, we can see exactly how the operating system's internal architecture scrambles to respond. In an iOS environment, this resurrection is led by a hidden conductor called DYLD, short for the dynamic linker. The dynamic linker acts as a scout, racing through system storage to locate visual frameworks and database libraries. Once located, DYLD instantly wires these disparate components into active memory so they communicate. Without this rapid structural assembly by the dynamic linker, the application remains a fractured pile of useless code. As the clock advances to the 250 to 350 millisecond window, the foundational code is assembled, and it is time to actually paint the visual user interface onto the screen. This introduces the ultimate bottleneck of the cold start, the main thread. This is a single computational process, and it is the only worker exclusively authorized to draw visuals for the user. A fatal error made by many developers is placing heavy synchronous tasks, like loading a massive database, directly onto this main thread. Because this worker stops to process background data, visual rendering halts and the 400 millisecond timer expires. The solution is lazy initialization. We detach that heavy process to a secondary track, allowing UI rendering to slide front. Elite engineers survive the cold start by intentionally choosing not to load the entire application. They provide the main thread with the absolute minimum required to create the illusion of readiness, letting everything else load quietly out of sight. When we zoom out from the microarchitecture of the phone, we see this exact engineering battle determining the survival of products in the global application market. There is a direct mathematical correlation between how fast an application opens and how long a user decides to keep it installed. A loading delay that is entirely invisible to the conscious mind still registers as a negative experience. It feels sluggish and broken subconsciously, which prompts immediate user abandonment. At a global scale, users instantly deleting a slow app to download a faster competitor translates directly into millions of dollars in lost revenue. Invisible technical architecture choices, like unblocking the main thread and implementing lazy initialization, are the ultimate deciders of whether billion-dollar tech companies live or die. When the engineering is precise, the timeline hits the 400 millisecond mark, the deadline is met, and the interface populates perfectly. This feeling of instantaneous digital gratification is a carefully constructed illusion, built through aggressive computational deferral. Every simple tap of a screen triggers a violently fast, highly orchestrated invisible war designed solely to win your attention before you can even blink.